Hello everyone, this is Usman with O-Level Mathematics. I'm back today with the second video on the topic vectors. Today, the topic of our discussion is going to be the addition and subtraction of vectors. Students, as I told you earlier, there are 6 main objectives that we have to attain our GCSE as well as IGCSE O-Levels syllabus. Number 1, calculate the magnitude of vector. Number 2, represent magnitude by directed line segments. Number 3, add or subtract vectors. And number 4, it is going to be multiply the vector by a scalar. Number 5, it is going to be use the sum and difference of two vectors to express single vectors. Last but not the least, students, you must know how to use position vectors. Objective number 1 and objective number 2, we have already covered them in the previous tutorial, whose link I am going to leave in the description box. In this particular tutorial, we are going to dig deep into objective number 3, that is addition and subtraction of the vectors, their meaning and their graphical representation. So students, let's build our intuition to visually add and subtract two vectors. Consider the vector A and the vector B that are going to add up to give us the vector C. So let's draw the first vector. It is going to be like this. Since A is being added with the vector B, so I have to bring the start of the vector B to the end of the vector A. That is going to be like this. Now the addition of these two vectors A and B is going to be the new vector, which will start from this point A and will end at the end of the second vector B, which is going to be like this, and it is going to represent the vector C equals to A plus B. Important realization that I want to make here is, whenever we are adding two vectors, like here in our case A and B, we will always bring this end of the first vector to the start of the second vector, or we have to bring the start of the second vector to the end of the first vector. Like this, students, we can also do it other way around. If we want to add B plus A, it doesn't make a difference. What I have to do here, I will draw the vector from the same point. I will draw the vector B first. Vector B, it is moving in the same direction as this vector, so it doesn't make a difference. Now we can bring the vector A at the end of the vector B. Bring the vector A start on the end of the vector B. It is going like this. So you see B plus A, again it is going to give you the same answer, that is equals to C. So order in case of vector addition doesn't matter. Let's now bring our discussion to the subtraction of the vectors. What if two of the given vectors A and B are going to be subtracted? And we know that subtraction means the addition of a negative number. So it means A plus, we are adding the negative sign of the B vector, and that is going to give us the answer C. So let's again draw the same vector A. It is going to look like this. Now students, just see, where is this B going? It is going in the upward direction. If I draw the negative of the vector B, it is going to be look like this. Same magnitude, but the direction is now the opposite. Now I'm going to take this vector B to the end of the vector A, and it is going to look like this. Now we will again starting from the point A and moving to the point B. So our final result, that is the addition of the vector A with the addition of the minus B, it will look like this, that is A plus minus B. So this time we are getting the negative of the first vector. Let us now explore the examples with the column vectors of the vector A and the vector B. Here what we are given in the example, consider students the vector A with the column vector 2 in the x direction, minus 3 in the y direction, and B is having 4 units in the x direction and 2 units in the y direction. Now what we have to find? Number 1, find the addition of the two vectors A and B. So how we are going to add it, students? What we are going to do, we are going to add the first component, that is the first coordinate, 2x component with the x component, that is 4. So 2 plus 4 is going to give us 6, and the y component with the y component, that is minus 3 plus 2, it is going to give us 6 minus 1. Similarly, if we want to find a minus b, what is the result we are going to get? We have to subtract the x component from the x component and the y component from the y component. So here in this case, 2 and 4, they are the x components, so 2 minus 4, it is going to give us minus 2. And similarly, minus 3 minus 2, it is going to give us minus 5. So very easy idea there. Now when it comes to represent these vectors graphically, then how we can represent them? Just consider this square box's grid, and what is the vector A? It is 2 units in the x direction, just like this, 1 2, and it is going through minus 3 units in the y direction, so 1 2 and 3. This is your A, and this is going to be your B, which is 4 units in the x direction, 1 2 3 4, and 2 units in the y direction, and their resultant in the graph is going to be this one, which is 1 2 3 4 5 6 units in the x direction and minus 1 unit in the y direction. Now if you compare it over here, it is the same like this graphically. So 6 unit in the x direction and negative 1 in the y direction. Now let's do it for this one. What we are going to have, the first vector A, it is like this. How many units? 1 2 3 1 2 2 units in the x direction, 1 2 3 minus 3 units in the y direction. And if we consider the B vector, now it is going to be the negative of the B. So the negative of this B is going to be minus 4 minus 2. Just look at here. The B vector is 1 2 3 4. Negative 4, 1 2, and negative 2 in the y direction. And its resultant is going to be this one, starting from A, the initial point of A, and ending at the terminal point, means the end point of minus B. So the resultant vector is moving how much? Look, in the x component 1 2, in the y direction 1 2 3 4 5, negative 5. So see the result over here. This is how we represent these vectors graphically. Now let us move to the example number 2, and this example 2 I have taken from the past paper of GCSE syllabus. Students, see in the question what we are given with. In the figure below, OT is equals to 3 times of OP, RS is 1/6 of RT, and Q is the midpoint of R, midpoint of PR. OP is equals to P and PR is equals to K. What we have to find? We have to find number 1 OR, number 2 RT vector, and number 3 QS vector. Now students, if you look at this diagram carefully, what is the first thing? We have to find the addition of two vectors OR. Now consider this is the line OR. You have to consider which two vectors are building this OR. See, OR is having its starting point at OP and its end point at PR. So these two vectors OP and PR are going to give us OR. So simply we can write OR as P, which is the OP vector, and Q, which is your PR vector. Now students, the second vector, which is RT. RT is this line starting from R and ending at T. Now if you think of the vectors two which are making this OR, this RT vector is made of RO and OT. So we can write RT equals to RO plus OT. RO we have already calculated in previous part, which is P plus Q, and RO is the same vector but in the opposite direction. So we have to take negative of OR, which is going to be minus PQ over here. Now consider the OT vector, which is given over here. OT is equals to 3 times of OP, and OP is equals to P. So it means that OT is going to be 3 times of P. If you simplify them, you are going to get this answer, 2P minus Q. Now let us consider the last part, which is QS. QS is starting from Q ending at S, but we know that Q is the midpoint of PR as given in the question. Now QS is the combination of two vectors QR and RS. So I can write QS as QR plus RS. What is the value of PQ? It is the half of PR, and PR is Q, so PQ is going to be Q by 2. Similarly, QR is going to be Q by 2. Now what is RS? And we know that RS is 1 by 6 times of RT, and we have already calculated our RT, that is 2P minus Q. So I can replace QR with Q divided by 2 and RS with 2P minus Q divided by 6. If you simplify them, we're going to get 2P plus 2Q divided by 6. And this brings us to the end of today's tutorial. As always, thank you very much for watching. I hope it will bring some value to your mathematical concepts.